Just check there's no. Okay, right. So we're just back to the schedule for the course. So the next step is looking at the Archer 2 scheduler, which is called Slurm. And we're going to look at how to write job submission scripts. And then you submit your job, and then you see you can then edit your scripts to control the resources that you use. So the idea of this is to understand basic Slurm commands and how to use the Archer 2 scheduler. In short, how to run your jobs to do work that is useful to you. It's sometimes, I mean, this Slurm is sometimes referred to as the scheduler or the job submission system or the batch system, but I'll try to use Slurm for short. There are various commands that will start with the letter S, and we'll show a few of these in a moment. But sinfo just gives you the current state of all the nodes. So as you can imagine, that one returns quite a bit of output, there being nearly 6,000 compute nodes on Archer 2. Sbatch is what you use to submit your job. And when you do that, you usually specify a Slurm script, which is something a bit like a bash script. If you've ever written any bash, well, you know, it's the sort of commands that you would normally type at the Linux prompt, module loads, setting environment variables, and so on. Then we can have SQ, where you can list the jobs in the queue. Normally, you would pass an option there, -u, to indicate that you're only interested in the jobs that you've submitted. You can then cancel a job. You would need to pass it the job ID. When you do sbatch, you immediately are shown the ID that's been assigned to that job, so allowing you to cancel it if you need to. You can run interactive jobs. You can run interactive jobs, and what that means is you're basically on a compute node as if you're using a logging node. So you've got the full resources of the compute node at your disposal, and you can do things there. And srun is actually a command you might run from within an interactive session, but normally that's a command that you'd put in your submission script. Okay, so I see that one person just joined us, Alistair. So I've just started, and we were just talking about the various commands that you use to interact with the Archer 2 job submission system, known as Slurm, and that's what you use to start jobs on the compute nodes and then to control them afterwards. So if you go into a login prompt now and you were to type sinfo, I might do that. I'll come out of here. TA882. I use my multiplexed SSH connection, which is still up, and I can use that. I think it was just sinfo. There wasn't anything, and I'm going to get absolutely loads of information coming back. I've also got some information about these DVN nodes. So those are the data visualization nodes, the pre or post processing nodes that I mentioned earlier. They're called DVN here, data visualization, but I think in the notes they're referred to as data analysis nodes. But all of the compute nodes generally have this sort of name format. They start NID and then they have some number, a number of digits at the end. So here you go. Here they all are, and you'll basically be shown the state that they're in. So certain numbers are in a given state. At the time that this output was captured for the course notes, the majority of the nodes were in the allocated state. Some were reserved. I think some are reserved by default for the short queue, which I'll talk about soon. And then there's others that are being drained, and that may be because there's a big job about to run, and so nodes need to be set aside to meet the requirements of that job. And then there are a reasonable number of nodes that are idle, that currently don't have any work assigned to them, so they're available for use. So the way things are, they're organized on within the Slurm job scheduling system, is that you have what are known as partitions. And I think there's one partition on Archer 2, it's called standard, and that will be usually available. There'll be like a status that it's indicated as up in normal operation. There'll be a time limit, meaning how long jobs can run on that particular partition. But this is superseded by something else within Slurm that's known as QoS, stands for quality of service. And so within the standard partition on Archer 2, there are different QoSs. There's a standard one, QoS, and then there's a short one, and then there's a long one for long jobs. And each of these partitions, well, the partition will have a number of nodes available, and then you'll be able to see all the nodes in a given list, which are listed here. And each of these nodes will be in various states. And I think up here in the sinfo command, it is broken down by the state the node is in. So they can be idle or allocated, as I said. They can be down because they're unavailable, or already mentioned draining. They can be reserved. They might be reserved for a course, or I think those nodes, there are nodes that are reserved for the short queue. So the short queue allows you to use up to 32 nodes for very short jobs. The maximum amount of time that they can run for is 20 minutes. And there are some nodes that might be listed as being down for maintenance. And I think that command allows you to look at individual nodes. But of course, like SFO, I think here it just orders the output, so it's a little bit clearer. So we can do that. We can run that. And you might want to understand a bit about sinfo. You can do man sinfo, and then you can go through there. So we did the -n option. If you wanted to know about that. I think we just missed the -l one. That wasn't shown. Go down. The -l puts out the detailed information, and yeah, it's done on a node by node basis. So you can also explore individual nodes and capture the output that you see. And again, the man sinfo command is useful here because you can basically in this particular command where you're getting the status for a particular node, the one that has this name or number, you have various character codes there that you can specify, and if you wanted to see what other character codes are available, you can just look through the output of man sinfo to see all those. So we're looking at, in this example, N, C, and M, all lowercase. So where's that? That's the list of node host names, and M, size of the memory per node. And what was the other one? Got C, I think. And that's the number of CPUs per node. So if we were to do that, I mean, I think there you go. So we've got the host name, great, and we got that as there's 256 CPUs. I'll talk about that in a moment, and the memory. You may have remembered from the hardware page that the memory was 256 gigabytes for a standard node. For the high memory nodes, it's 512, but we don't see 256 here. We see something like a bit more than 227 gigabytes. And the reason is that on any compute node, an operating system is running, so some of the memory is reserved for the operating system, is needed for the operating system to run. So that 227 or so gigabytes is what's available for your job, should it be allocated to this node number 1000, it's the memory that it can use. So it's the memory that it can allocate during execution. You know, and so you don't have a problem. You won't ever be in a situation where you use so much memory that you cause the operating system to fail. So I think there's just a wee question here to experiment with this command. You could try with other node numbers. I mean, basically anything, any number that was returned from up here, you might be able to do a range. I think I'll give this a go. I think that will work. I'm not sure. This may fail. I don't know if I have to do it with both. No, it didn't like that. Maybe didn't like that either. So it only works for single nodes. I was wondering if it could work for a list. There might be a way of doing that. I'm still wondering if. No, I'll give up on that. So this was, anyway, this exercise was about just trying to explore an individual compute node anyway. I was just wondering if it could do a range. So, I mean, it's such a simple question exercise that I'll just leave that, and you can do that in your own time. You can experiment with things, and the man-s info gives some really useful output. If you're stuck on anything, you can just consult that most of the time. I think what the solution says. Yeah, so I mentioned this. Surprisingly, from the output, you've got 256 CPUs are listed. Well, these are known as logical cores rather than physical cores. And the idea here is that each physical core actually supports 2 hardware threads. That's known as symmetric multi-threading. Most times when you run a job, you'll specify that you're not using multi-threading. So you only be running just one process on a core. So in effect, you're just using the 128 or so physical cores. But the way, this is sometimes known as hyper, it's also known as hyper-threading also. Yeah, thanks, Vanil. Yeah, I just needed to use a square brackets to indicate the range. That's great, thank you. Yeah, so getting back to this, there's such a thing, it's normally referred to as hyper-threading, and you enable that, and you can have 2 processes running per core because you have this idea of logical cores. And the way to think of that as if when it's as if like when the work is being done on a particular core, when some computation is taking place, there's actually a pipeline that's being it's being worked through. There's various stages in the pipeline. It may be to fetch a command, it may be to look up a particular memory address, it may be to do a particular to do a particular mathematical operation. And the idea is then you can do some parallelizing because of this pipeline, because when one process on the core is at one stage in the pipeline, another process will be in another stage at another stage. So one process might be doing a lookup, and another process is at the kind of mathematical operation stage in the pipeline. So you can get a bit of parallel processing there, and that's what's normally involved when you use hyperthreading or symmetric multi-threading. So that's why we have 256. It's not that there are 256 physical cores on the node. What it is that each core can support 2 threads if needed. So I'll now look at the job submission scripts, and this is the syntax that you'll use. So this is this script might have a name, so it'll be something like submit.ll, and then you go to the folder on Archer 2 where that script exists, and then you would do sbatch space submit.ll, and this is the sort of content that you would have inside it. You have a bit above here to indicate that this is like a bash script, and then you have the hash. I call those that's the hash character, and sbatch. So these are the sbatch directives that basically describe the resources that your job will need. So my job name is my_MPI_job. So that's just to identify my job. Number of nodes I'll be using 2 nodes, and I'll be running 128 tasks per node, and each task will use just 1 CPU, and I'll be running for 10 minutes, and obviously I'll be charged for that job, and the budget I'll be charged against is for whatever the project happens to be. So in this case, because it's the Archer 2 package users training course, it's TA082, but this will change for whatever budget code you have for the project that you were given on Archer 2. And now I also specify the partition I'm using, standard, and I'm also and which quality of service I'm using. I'm using the short the short queue. And then within this, I'm loading something called well, I'm not sure how to pronounce it, XI, I pronounce that. So this is just a tool that allows you to check that something is distributed in the way you expect. So that will, when you run this, and you run this down here using the srun command, which is the parallel job launcher, and then you'll get some output to say, this task was assigned to this core on this node, and so on and so on and so on. And you can confirm that your sbatch directives and your srun command is working as you expected. So you might test something out with XI, and then when you've done that, when you're happy with that, you would then use that with your actual code. There's a few other things you would have noticed. There's an environment variable called omp_num_thread, and that's set to 1. So that's just making it clear that each of the tasks only has 1 thread, and we're not using any multi-threading here. So that means it is 1 task per CPU. We're not using multi-threading or any hyper-threading. We're specifying a distribution of block. Now that, I'll explain that a little bit. I'll try not to go into too much detail. The first block is to do with the way that the various tasks are assigned across, it's the internode assignment. So it's how the task will be assigned on a node by node basis across all of the nodes that have been assigned to the job. The second block refers to the way that the tasks will be distributed within the node. So this block, you can have other things, like you can have a cyclic instead of block. But what block means is that you're just assigning things on a first, on a kind of first come first serve basis. So I've got 2 nodes, and I've got 128 tasks per node. That means the first task would be assigned to the first core on the first node, the second task to the second core on the first node, and so on and so on and so on, until you get to the last core of the second node. If I change the second block to cyclic, what actually happens is then there's a round robin assignment done across the NUMA regions on the node. So on each Archer 2 node, there are 8 NUMA regions. So what happens is the first task goes into the first core of the first NUMA region. The second task goes into the first core of the second NUMA region. So they're about 16 cores, well, they're exactly 16 cores apart. And then with the first block, if you were to change that to cyclic, what would happen is the first task goes on the first core of the first node. The second task goes to the first core of the second node, and so on and so on. But again, you can find out about these options by running man srun. So that kind of explains that. I'll go into also what's useful to look at. I'm just going to the Archer 2 docs again, and I'm looking at running jobs. And when you go into a particular page, normally this bit on the right hand side is useful because that shows you the sections on the page. And if I go directly to quality of service, and it just shows you the different quality of services I have and the limitations I have for each QoS. So there's a standard one. Maximum number of jobs I can run at any one time is 1,024 per node. Maximum number of jobs, maximum number of nodes per job, maximum wall time, how many of those jobs I can have queued at any one time, how many can be running at any one time. And then I've got various other quality of services such as high memory. So this is how you access the 512 gigabyte nodes. You need to use the high memory QoS. I've got one for doing task farming. So that's typically when you might be doing work such that each task is entirely independent from the other task. So it's so independent that they don't need to communicate. We've got the short QoS, so that's for 32 nodes. That's the maximum job size. They can't execute for longer than 20 minutes though. And I've got a long QoS if I want to run jobs that will go on for more than a day, for up to a maximum of 2 days. And then I've got large scale jobs and so on. So also I should mention that there is more than one partition. There's a standard partition and there's also the high mem partition. So if you wanted to use the high mem QoS, you'd need to use the high mem partition also. And there's a serial partition, which is what you'd use to access the data visualization nodes or the data analysis nodes. So that's just a useful, I often consult this part of the docs quite frequently if I want to check what the particular limit is on a particular QoS. So back to the notes. So to submit a job, you'd write your job script as just shown above there, and you type sbatch space and then the name of the script, and then it will tell you the ID that was assigned to that job, and then that's what you would then use to find your job in amongst all the jobs that happen to have been either submitted or are running on Archer 2 at the current time. So that would be quite a lot of information to have to scroll through. So usually you would limit the jobs returned that were only submitted by you, or from within your user account. And you can do that using this as it appears there. So it's using the $user, so it's using the user environment variable, which already should be set to your user name. You can cancel jobs by simply running scancel and then the ID of the job that was returned when you ran sbatch to submit the job originally. You can batch cancel jobs, which is what's going on here. So this command is cancelling all jobs that are in the pending state and that have been submitted by you. So what you might have done, you might have done a situation where you've accidentally submitted a job that can never run for whatever reason. So it's permanently in the pending state. So if you want to just clear out those jobs, this is the sort of command that you would run. And yeah, when you actually want to launch the parallel application from within your job script or from within an interactive session, you use the srun command, which is another Slurm command. So these can be quite complicated, these commands, especially if you're doing something like a heterogeneous job, especially where you're being very particular about which cores are assigned to run which executables. But here, just showing an example in a typical form. Maybe we've got this hint, this no multi-thread hint, to say that we're not going to use the hyperthreads that you have available, 2 per core. We're not using them, and we're just doing a straightforward distribution of tasks to node calls, this block. And so we can, when the job runs, we'll get some output, and the general format of the output will be something like this, in that we have slurm hyphen, then the job ID dot out, and and you may specify separate fields for the standard output and the error output. So, sorry, separate files for the standard output and the error output, if you like, or you can make them the same, and you can do so in the batch submission script. So I think there's an example here to work through, which you can just do this. If you just if you can log into your Archer 2 account, and then yeah, so I was just going to say this. So that's a warning to say, because the compute nodes can't see /home, it's saying that you should run this from /work. So what will be happening there is that the job's been submitted, but at the same time it's going to look up your batch script in order to find out what to do, because the content of this batch script that I'm showing you here, that actually needs to run on what's known as the lead node in the set of nodes that are assigned to your job. So these kind of commands actually just run on one node, but then get the environment that it sets up gets replicated across all the nodes. So if you go onto your /work area, I might actually show you a little bit of a convenient thing to do to set up. So I'll just do that. I'll just come out of here and go back in. So I'm in my home area, and I've done a few things in here before, and I've got a script called cdwork.sh, and if I can just output the contents of that script by doing a cat command. And it's a very simple script. It's just a bash script, and it has a command in it which is cd, and what that's doing is it's taken my home environment variable. Home environment variable points to that, and it's taken that and it's replacing. It's doing a substitution. It's replacing home, that's this home here, with work. So that becomes work TA 082 and I just have something else in that I should show you. So I'm still in my home folder, but if I do a listing, I do -al to list everything in long form, you see I've got a script here called .bashrc, and if I'll go into there, I've got something set up. I've got a number of things that I set up here, but in particular I've got something called an alias, and what this alias means is that when I type that cdw, that's effectively a command which when I run actually does this. It sources my cd work script. In other words, it automatically takes me into my work area. I can put the details of this on the Etherpad during a break, but what this means is now I can just do that, and I'm straight away I'm in my work area. So that I find that quite convenient, especially because of this compute nodes only seeing /work issue. So I've got a submission script here. I tend to refer to my Slurm scripts with a .ll extension rather than .slurm. It's just more succinct. And so that's basically what is in the course notes. It's pretty much the same. So when you do this and you submit the job from /work, you should find that it works. And so I'm going to do that. And if I quickly do an SQ with my username, it says it's running. It's not going to run for very long because it's just a simple test to make sure that the tasks are distributed correctly. CG tells me that it's starting to terminate. And now it's gone, it's disappeared from the queue. If I wanted to, there's a way of checking jobs that have run in the past. You can use something called the sact command, or what I mean is SACCT, and normally you specify it with -J to indicate the job ID. So I just do that now, because I can see, and it will just give me the details of that job that I ran. And there are various components of the job. There's the batch process itself. There's the actual code that I ran, and I ran it across 2 nodes, which equates to this 512 logical cores instead of 256 physical CPUs. I can get other information, which is often more, which is also useful, and I can do things like this. So if I was just interested in how long the job ran for, I might do this, and it will tell me that it ran for 12 seconds in total. The actual xthigh part ran for 5 seconds. I might want to make that a bit clearer so I know which part of the job is being referred to. I do this. I specify an extra field so it appears. You notice I've got a plus at the end here. That just means that the default length for that field isn't sufficient, and I can enlarge the field width by using the % sign, and then I can set it to 20 characters, say, and that should now appear in full, and it does. If I wanted to make it a bit better, I'll add the job name. So these are sorts of things you can do. You might be also interested in the start time and the end time. If you want to find out more about which fields you can consult, you can again do mem s act, and there's parts of this that I find useful. You've got all of the fields available that you can output. You saw some of these. We did the elapsed one, but there's many more. And then if you scroll down a bit further, you can see that you can get descriptions for each of these. So what's useful here is that you can get something called average RSS, which will tell you the average amount of memory used on a node across your job, and then or the amount of energy consumed by your job in joules. And then there's everything in here. You can also find out what the maximum amount of node memory used for all the nodes assigned to your job also, and so on. So man sact is something I've run often just to remind myself of which things I can view in jobs that I've run, find out the details. So I take it then that I just want to check with everyone that everyone is able to submit a job and they were able to run that XI program and it returns some output. Can anyone, if anyone isn't able to do that or wasn't able to do that, can they just let me know in the chat or just speak up? Or which account? Well, you can use the training account, but I mean, if you have your own personal account already, then just use that one if that's easier for you. What you would need to do is you would need to change the account value used in the SBatch directives. So you need to set that to the budget that you use for the project that your user account is part of. And I wouldn't worry about, I mean, you won't be using much Node. I think I don't have the credit. So, okay, thanks, Rebecca. This is how that worked. Well, if you don't have the credit, then right. So, what you will need to do is within Safe. So I've just gone back to my Safe window. You'll need to go under login accounts, and you'll need to request a logging account, and you do that, and then the project here you type in TO82. So that's for the course that's running on the 24th of November, and you go on next, and you'll just go through here. I'll try and and then you have to put in your username that you want. So I'll choose one that's unique to the TOA082 project. And at that point that you can upload your key. I usually create a unique key pair for each account I have on Archer 2, and so on. So that's what you would need to do there. Okay, so I'll leave you to do that, Ruben, and then we can catch up during the break. So just see what else there is in here. So I think there was, yeah, so checking the progress of the job, breaking that down so you cut down the amount of output return, doing scancel, doing srun, looking at what's returned. Okay, so you've run the job, and let's go back to my, I should see, I ran some jobs a few days ago. You can tell by the dates, but this was the one I ran recently, and I can just do a vi on there, and I can look, and this is the output from XI. So it's telling me I had 256 MPI ranks. So MPI stands for Message Passing Interface. It's the communications library I'm using, and well, the implementation of it is Cray MPitch in this case. So for each of the tasks, the first task is running on node 0, it's rank 0, thread 0, and its affinity is 0, meaning that it's assigned. So these are 0 based. I should mention. So the MPI ranks start from 0, and this is running on the first CPU on the first node. The second task is on the first. The second task is on the second CPU on the first node. So that's known as 1, and so on and so on. And you see this follows the block distribution that I described earlier. So you'd have to go through the first, the 128 lines before you start to get to those tasks that have been mapped to CPUs on the second node, known as node 1, because everything 0 based. So I can see that worked as expected. So I'll just talk about underpopulation of nodes. So sometimes you might want to do this if the job that you're doing is memory intensive and requires a lot of memory, such that you have to underpopulate the node, meaning that you'd have to run fewer than 128 tasks per node, such that each task therefore had access to a greater share of the 256 gigabytes that's available on an Archer 2 compute node. And then also you would specify in your job script such that the tasks that you have are spread evenly across the node, so that they're basically you're maximizing the bandwidth, the bandwidth to the memory that each of those tasks can avail themselves of. So this is what is happening here with these commands. So these can be specified as SBatch directives at the top of a submission script, or they can be passed to srun. So that's the number of tasks you're running per node, obviously, and if it's less than 128, then you're underpopulating that node. And then if you're saying that each task is 2 CPUs, then there'll be a stride pattern across the node, such that there'll be a free, well, it may be, depends actually on your task, but if the task is single threaded, then there'll be a free core between each task. But it might be, you might be doing what's known as a hybrid run, where you're using MPI and OpenMP. And OpenMP is something where threads can communicate via memory. So what that means is that with OpenMP, communication is restricted to within a node, because one node can't see the memory of another node. we'll talk about that in the section that's after this, I think. So we've got an exercise here in that, can you change the SBatch options you would use to run XDI on 4 nodes with 32 processes per node. And I should also mention, yeah, these actually can be passed to SBatch as well as being set up in as SBatch directives within the script. I think I mentioned that these could be passed to srun, but no, actually, I think it's SBatch that you would pass them to. So I'll just give you a minute or two to do this exercise. Okay, we'll just go over a solution to this. So the question was, can you state the SBatch options you would use to run XDI on 4 nodes with 32 processes per node? So we could do it like this. And if I go back to my submission script, I'll go in there and I change it here. So I want to run 32 tasks per node, and I want to cross them across 4 nodes. And if I wanted to evenly space them, I could do something like this. I could just put 4 here, so they're evenly spaced. And then if I submit that, and that runs, right. So you can see that the size of that output file is smaller than the other ones. Well, that's because even though I'm running on 4 nodes, I'm running sort of half the number of tasks. So I've got half as many lines in the XDI output. I had 2 nodes fully populated, 256. So I've got 4 nodes, 32, which is 128. So I just have to take a look at that. So there you go. I've got these spaced out at 32, and then I've got the first task is there, and those are the CPUs that it could have available from 0 to 3 and 4 to 7 and so on. I could have done it in a different way. So I could have just gone back and said, well, actually, I know that my tasks are going to be single threaded. I only want 1 CPU, but I do want to spread things out a little bit. So I want to go across the NUMA regions on the node. And I'll do that. So that's specifying the assignment within the node. I'll just submit that job. And wait for that to end, as it has done. And now look into that file. So you can see here, I've got my 28 ranks, my 4 lots of 32. So on the first node, that's gone on to the first CPU. The second task onto the first node, but onto the CPU number 16, which is the first one in the second NUMA region, and so on and so on. And I go through, once I've exhausted all of the NUMA regions, I go back to the first one, the first NUMA region on that node, and I continue doing that until I've gone through my 32 tasks. So there'll be 4 per NUMA region, and then I'll do the same, repeat the same pattern on nodes 1, 2, and 3. So that's what you do there. I'll move on to hybrid MPI and OpenMP jobs. So this is you run an MPI job and it's a parallel job. You'll need to do some means of communicating between the various tasks, and the MPI tasks will run on separate nodes, they will run on separate cores within a node or on cores across nodes. And MPI is what you need to do communication, if you're going out with a single node. But it can be that you may have each tasks may have work that can be done by a closely knit set of threads that can basically communicate amongst themselves via memory, memory on the node, of course. So you can have a situation where you're specifying a certain number of MPI tasks, but each of those tasks will occasionally use a number of OpenMP threads. And this is how you would set up such an environment. So we've got something, so the CPUs per task option, that is now, instead of just spacing tasks, just merely spacing tasks across the node, you'd use that to indicate how many OpenMP threads, or you basically indicate the cores which will be used to run the OpenMP threads. And then this CPUs per task will be the same as the OMP numThreads environment variable, the number of threads per MPI task. And in order to get the correct pattern of thread pinning, you would then use another environment variable called OMP places and set that to cores. And so this is what happens here. In this example here, we're running across 2 nodes. We've got 8 tasks per node, and each task is going to be using 16 CPUs. And our OMP numThreads is therefore also 16, meaning each task will run on occasion 16 OpenMP threads, and they'll be doing a particular specialized piece of work. It might be a loop where the iterations of which can be done in parallel. It'd be something like that. And then we run things, and we'll get the you can do the same thing again. You can copy this into a submission script within your Archer 2 training account or other account, and this is the sort of output that you'll then get from XSci. So again, on this node, we've got a particular task which rank 0, the first task, and these 16 rows here all have the same rank, because on the same MPI task or process, we have 16 threads, 0 to 15, and each of those are assigned to a unique core, so to a unique CPU. So I should explain, I use core, or I may use CPU. I'm using them interchangeably. They mean the same thing in this context, and so on. And you go on to the next MPI task, and you've got the next set of 16 threads, and so on, until you go through to the other node. So that's what you would do if you're wanting to run an MPI OpenMP hybrid job. So each Archer 2 compute node, I've sort of mentioned this already, is made up of 8 NUMA regions, NUMA standing for non-uniform memory access regions. There's 4 per socket, so this gets a bit, there's quite a lot of detail. It's a bit like breaking down measurements in their different type of units. So there's because there are 2 sockets on the node, there are therefore 4 NUMA regions per socket. And so you have 8 NUMA regions in total, 16 calls therefore within each NUMA region, because 16 times 8 is 128. So programs where the threads of a process span multiple NUMA regions are likely to be much less efficient. So we recommend using thread counts that fit well into the Archer 2 compute node layout. So when you have something like what we've just done, when you have 8 MPI processes per node and 16 OpenMP threads per process or task, what that is doing is each OpenMP group is then assigned to 1 NUMA region. But you could do it differently, so you could have 2 OpenMP groups per NUMA region, or 4 or 8, as long as it's some kind of whole number. You just don't want a situation where maybe you had one MPI task. If you had an MPI task that had, if you had 4 MPI processes per node, and each MPI task therefore had 32 OpenMP threads, you'll be spanning more than 1 NUMA region. So those OpenMP threads that may have to be communicating with each other via memory, that will take a bit longer because they're going across NUMA regions. So finally, I think that's the last bit. And this section is just mentioned interactive jobs. So an interactive job might be something that you know can run on 1 node or just a very few number of nodes, and might be something that you'll want to try out. It might be an MPI code that you've written from scratch, and you just want to make sure that it does run in the way you'd expect. And you're not probably going to do a full run. You're just making sure that it starts okay and can pick up its input and can do a basic bit of processing and output. So it's just a debugging exercise, really, just making sure. So you'd be on your logging node, say on Archer 2, which is indicated here by LN01. You do the same thing. You kind of export OMP num thread equals 1. You load the XI module, and then you start srun for a particular job, and you're specifying here that you're using the standard partition, and you're using the short QoS, you're using a certain number of nodes. So let's have a go at doing this. So I'm just going to do that, load that module, and I'm going to try and, because this is going to be quite a long command, just check that is doing what. So the partition, fine, nodes, that looks okay. So it's waiting for the resources to come available. It's waiting for that job. And then it's just going to run that directly. So and then it's become available, it's run, and then it's produced the output there. You can do things a bit differently. I'll just show you how to do that. I think I'll log into another account. So this is just something that I have set up earlier. Again, I've also got the cdw command set up here. I think, yeah, I've got something called srun. That's just a script, and I think if I just run that, it does the same sort of thing, but it leaves me on the compute node actually. So I'll just show you what's in srun.sh. So there you are. I've got a prompt. I'm within a bash environment, and I'm on this compute node that was assigned to me. So now I can actually do things on the compute node. So I could run a parallel job that's using 128 cores, say. So I've got, that just ran directly from the login node, this what I did here. But if I wanted to actually have a bit more control, have a finer grain control, if I wanted to then do particular commands on the compute node, I can do that. So I just exit from here, and I go back into my logging node. Oops, actually, I just realized this isn't. So I just make that larger so you can see what I did. So I logged into another account I have on Archer 2, which is in a project called Z19. And so I'll just show you the command that I actually run such that it left me with a bash shell on the compute node. So that's basically what I had there. So that's this command. This particular srun command is split up over multiple lines in my script. Maybe just to make it easier, I'll put it in an editor. I don't know why that's there. You can ignore that bit. I just delete that. It's the same as the srun command that you just saw. I'm on the same partition, actually, the same QoS. I just have a different account number. But this is the key thing, to say that I want to go directly into a bash shell environment on the compute node. There you go. So if you wanted finer grained control during an interactive session, that's how you do it. It's asking me to save. I'll close that now. And I go back to here. So that concludes the section to do with the Slurm scheduler. You can find out all about this on the running jobs page. This is all things to do with the batch, or to do with Slurm basically, and you can find example job submission scripts, the hybrid ones. You can also do things. You can run multiple srun commands in a job script, and you can divide a job that way. There should be something to do with running. Oh, it's referred to as inhomogeneous rather than heterogeneous. But those kind of subjobs where you may have different executables assigned to different calls on a node. You've got things to do with how to do the the process placement. Oh, and here's the stuff to do with heterogeneous jobs. And I was looking actually for stuff to do with interactive jobs. There it is. So you can say that there's two ways of doing it. You can run salloc, or you can do the srun, which is what I just did. So all this information is here in much more detail than we actually have in this kind of introductory course. So you can find them there. Is there anyone that has any questions at this stage? No, I think everyone's happy. So I'll just go on to the next part of this course, which is learning how to be a good Archer 2 citizen. And then after that, there'll be a break. Okay, so the main thing, I think the first thing, is the fact that login nodes are a shared resource. Do not run jobs directly on the login node. You can do a quick test if that's something less than 5 minutes, and not using all 128 cores on the login node. So you have to remember that these nodes could be supporting, 100 or so users. If you make a mistake and run something you shouldn't, you can quickly list the processes that are running at the moment using that command, a psux, and then you can find a process ID and do a kill to kill that. So those are things that are running at the moment. It's not very exciting. There isn't anything. But imagine if I had just started some, I don't know, if I just run a Python script that was trying to do some machine learning on the CPUs of the login node, I might see a command up here that started Python, blah, 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 TensorFlow.py or something like that. I would think, oh, I've got to stop that, I've got to stop that. And I would then go to the PID column and find that PID and then type kill and then put that number, and then that will kill things. And then you'll avoid receiving a warning email from the Archer 2 help desk. Things like that, if they're not attended to, will be caught by the systems team at Archer 2. They then inform the help desk staff. If it persists, then whatever it is that's monopolizing the login node will be terminated by systems. But whatever happens, the user concerned will always be contacted to point out what's happened and then to ask them if they need help in submitting jobs on the compute nodes. There's a quite bug in this script that didn't make it through. So I'm just gonna scroll down so you can't see the answer. So which of these commands would probably be okay to run on the logging node? If you can just say what you think, if you can just have a think about that and just post a number of those, the number of the command, those ones that you think you can run, if you could just put them in there. Let's see what people. Yeah, 3's okay. Not one though. So I think 2, 3, and 5 are okay. It's normally okay to do a make, assuming that it's not a make that's going to take hours, or maybe it's not a parallel make. You can do make space J 8, say, to indicate that you're going to do the make. It's sort of you'll be doing it in parallel threads, so you'd be potentially using 8 cores, but that's not as shown in this example. Yeah, you can do something like a bash script, which is what is implied by this create_directories, and you can do something like an archiving command like the tar. The Python script, you don't know what it's going to do really. It's a physics simulation. It might be using MPI for pi, and so using all the cores on the logging node potentially, and obviously 4, which looks like it's doing a molecular dynamics simulation. You wouldn't run that. So that's that. The other thing is, do not share your login credentials. Sometimes you can get situations where people attempt to log into account from another Archer 2 account, like account sharing, and that's something that can crop up when I think maybe a PhD supervisor is talking to their postgrad and they're saying, oh yeah, in order to run this, you need that file. I've got that file in my account. Or just go into my account from here, and then that will be picked up by systems as an example of account sharing. So what needs to happen is that the supervisor would go back to their desk, and he or she would then copy the file to a suitable shared folder. You'd probably be in the same project, so you would use this so-called inner shared folder, and then the postgrad will be able to pick up the file. So these sorts of things can happen by accident, but they're always flagged up when systems find out, and then it gets passed on to the Archer 2 help desk, and then they will contact the users concerned, and usually the users concerned will need to change their access credentials, change their passwords. Generally, another thing that can go wrong is that you've got your first job you intend to run. It's a fairly complicated batch submission scripts you've put together. You've not done this before, so you're a little unfamiliar with things. But you want to wait for a large number of cores. Let's say that you need all the cores on 200 nodes. So you submit the job, and you wait a while for those 200 nodes to become free, say, and there's actually a mistake in your script that causes that job to fail almost immediately. So 200 nodes isn't very many. Let's say it's 2,000 nodes. So you've waited all that time, and then it's failed straight away. So now you've got to correct that script and wait that time again, potentially. So you'd want to avoid that by actually testing a very smaller version of that job, maybe one ideally that uses just one node on the short queue that can run for less than 20 minutes, and you can then quickly understand if your job script and your actual parallel code that you're calling via srun actually works as expected. I mean, it's a really good idea to actually, whatever you do, can you do a shortened version of it so that you can quickly determine that everything works? The last thing you want, I mean, what I described earlier is one way in which things can go wrong, in that you've just wasted time potentially, but even worse, you could waste resource. There might be a bug in your parallel code that you get to a certain point and the code just freezes. And so what would happen is that say you want to run on 1,000 nodes for a full day, the job gets to a point where it freezes after an hour of runtime, but because it halts, it doesn't fail or abort or anything, the job itself continues. So it continues. You're just monopolized. You're just holding that 1,000 nodes, but it's not being used for anything, and no other user can use those 1,000 nodes, and you're just burning through resource. I mean, that's kind of the worst thing that can happen. So doing short test jobs is a really good way of avoiding this. And also have a backup plan. Obviously, that's the sort of thing that we encourage. Well, actually, it's required for when you apply for time on Archer 2. There are things called technical assessment forms. The forms are different depending on exactly what sort of time you're trying to apply for. It usually comes under different schemes. You might have a sort of a project which is an extension of another one. So we already know that the code that you use run okay. So kind of the requirements for the technical assessment are a bit lighter. But if you're applying for time for the first time, then we would need to know what code you're using. We need to know how well your code scales over the number of nodes you intend to use, and we'd also need a backup plan. So we need to have some idea of number of jobs you intend to run, how much data you think you're going to generate, and how much of that data you're then going to need to take. You're going to need to download from Archer 2 and store, and how you're going to do that. What sort of, are you going to use rsync, or are you going to use something else? So your data is your responsibility, but things like this is covered in the Archer 2 docs. I think because you've got this section here, data management and transfer, and you've got a bit of information on data management, including the RDF. This whole thing stands for Remote Data Facility as a Service, and things such as this. There's other things like grid FTP. So transferring data, I think this is something that we kind of covered about. Things to have in mind: the disk speed. The Archer 2 work file systems are highly parallel, so this allows them to support a very high data bandwidth. So you may find your transfer speed is limited by the disk performance of that end. So if you're transferring data from one system to another, it's basically the chain is only as strong as the weakest link. So you've got things to consider like the metadata performance. This would be a problem if you're transferring large numbers of files, which you can avoid by archiving files into a single larger file. Network speed, yeah, so you're limited by the slowest section of the network, and firewall. The presence of firewalls may limit the transfer speeds also. So, I mean, as with resubmit a job, you would maybe do a smaller version of it as a kind of a sanity check. It's the same thing with transferring large amounts of data. If you've got something set up, you've got a particular command put together, you're using a particular encryption algorithm, maybe you're going to compress things in a certain way, you really don't want to just do it the whole thing first time. Again, you maybe want to do like a small section of the data that you need to back up, maybe just one folder's worth of files, say that's about 10, and you do that, and you just check things out that it works, and also there's an opportunity to time how long the transfer took, and then you can extrapolate from there to figure out how long it will take you to transfer all of the data that you need to do. So the key points: be careful how you use the logging node. Your data on the system is your responsibility. It's only stuff on /home that is actually backed up. Don't run stuff on the logging node. Yeah. And again, don't run stuff on the login node. It's a bit like a Fight Club style of key points. So I'll just go to a break. Does anyone have any questions about the material we've just been through? I think we'll have a break until about, we'll make it a bit longer. We can have a break until 2:30. And I think I need to help Ruben in setting up an account on TA082, so I'll do that. So we'll, Ruben said he's fine. That's great, Ruben. Okay, in that case, I think we'll still have a bit of a longer break. We'll go until, because this is scheduled to end at 4 o'clock, so we'll still have 90 minutes when we come back at 2:30, unless, I don't know if people need to get away earlier. Are people happy for me if we just take a 15-minute break now? Yep. Okay. I think the consensus is that's okay. So I'll see you at 30 minutes past 2. Okay. So before the break, we were just looking at how to be a good Archer 2 citizen. I've done that. So now we're going to look at SAFE, which is the website that you use to manage your machine accounts, and there may be more than one on Archer 2. And it could also, SAFE could also be used to manage machine accounts on other machines hosted at EPCC. Mainly Cirrus is the other one, which is known as a tier 2 machine. Archer 2 is a tier 1 machine because it's national, and I mean, Cirrus is just a smaller machine. Really, it's Intel based, and it also has GPU nodes. So anyway, we're going to talk about SAFE and Archer 2, and how to manage your Archer 2 account, how to do things like record your research outputs and so on, and how to look at reports of your historical use. You might want to do that if you were the PI for a project and you wanted to see how much resource had been used over the last 3 months, or which users had run the most jobs, and so on, things like that. So I think I mentioned briefly, you can have multiple login accounts, and you may well do, as you use Archer 2, you may be involved in more than one project at the same time. So you can have multiple Archer 2 accounts associated with a single SAFE account. Just, can you delete accounts? What you can do is specify that they are to be retired, and then they go into retired state. And I think eventually they will be deleted such that they won't show up in SAFE. So that's what you can do if you look here. So for example, I'm on my training account page within SAFE, and you'll notice down here there's a retire button. So that will kick off a process that will, I think it doesn't happen automatically, but over the coming months, then the folders and so on that the passed to your user account on their home and work file systems will be removed. So yeah, it's not an automatic thing for obvious reasons, but you can initiate the retirement process by clicking on this retire button in the SAFE for a particular account. So there are some things you can do, such as you can do something called a single sign-on. So each your institution, your university may have a kind of institution, what's known as an institution SSO page, single sign-on, and you can specify that that is to be used rather than your personal safe login credentials. So when you log into Safe, I'm not talking about your machine account, but Safe, you use your email address and your safe password. So it might be to set up the single sign-on, you do something like this. You'll go to your details and you go into register identities, and it's this thing here, the register institutional ID, and you go there, and then you have to go into, you see that the link has changed in the browser. You're on here, you should be able to find the institution for the single sign-on feature. You'll type in the name of your organization, but whatever it happens to be. So that, I think, is something that you might do for convenience. So the institutional SSO requires that your local institution has set up their system to allow accounts to be linked in this way. So it's our experience that most of the UK-based institutions, but worldwide, it's somewhat patchy. You can also might want to change your email notification preferences. So these are the emails you receive automatically. Again, you go to your details and then you go to update email settings. And these are the things. So you can see for me, I've just included everything. So things to do with debug only. So because I'm also in, I work at EPCC, I will have that checked. There's other things like changes to the queue state. It might be that maybe the long queue may be offline for a short period of time, general service news or major announcements. We can have announcements like that, say over the summer where there were some unusually hot days, and they're concerned about the cooling system at Archer 2 would be able to cope with higher temperatures. What was done was that the number of nodes available was reduced. And I think it was reduced to about 1,000 at one point, or it may have been reduced by 1,000. So that sort of thing would be a major announcement, and so you'd really want to be signed up for that, so you would know that there for reasons that are expected to be short-term reasons. There's a restriction in the number of nodes available. They may also be service news, where that's like a weekly email, so we keep you aware of the training courses that are coming up, or we'll keep you aware of new module releases on Archer 2. There might be a new programming environment that comes with later versions of compilers and MPI libraries and so on. We can have also things like system status notifications. So that's for maintenance that has been planned. So there possibly will be one coming up when we'll need to upgrade the operating system, say on Archer 2. And there'll need to be some amount of downtime for that. So yes, you can have multiple machine login accounts for a single safe account, and then for each of those machine accounts, you can look at which resources are available to you, and you can also check how many resources you are using. I'll just remind you of that. So I can go down to, there you go. You can see the resources I'm using on the file system and the budget I'm using. I think there is a bit of a lag between what you see on Safe and what is actually the case on Archer 2. I think the Safe gets updated about twice a day. So things won't appear, if you deleted a load of files from within your Archer 2 account, you might not see that appearing in Safe straight away. you've also got, this is where you pick up your initial login password. So for when you join a project for the first time, you'll have an initial login password that you will go to by clicking on your view login account password. Now, crucially, when you then go on to use that password and you log in and you're prompted to change it to one that only you know, obviously what's stored here, you click on view login account, that now is out of date. It doesn't keep track with the password that you are using, which is supposed to be only be known to you. So for obvious reasons, it wouldn't be possible. And then you can add SSH keys to your account using the add credentials button. So it may be the case that you may want to access Archer 2 from different machines. You may have a machine you use at different locations that you work at your university. You may be working at more than one institution. So what I would advise, you don't want to be transporting SSH key pairs between different organizations or universities or whatever. If you're logging in from a different place, you should create a different SSH key pair that you use just for that location that you're accessing Archer 2 from. And then there's requesting access to licensed software. Again, I've shown that the terminology that's used within SAFE is you request access to a package, and you do that, and you'd need to provide details of the license on the web form, and then you submit that, and then that will be checked with the licensing the license service for that code. Yes, I think the question is, can I access Archer 2 with the same credentials on the same machine if I go abroad? So you're taking something like a laptop abroad. Yes. So when you request access, you provide the license details. That goes to the Archer 2 help desk. Someone then will contact the authority, whoever it is that manages the licensing for that particular code, be it VASP or CASTEP. They will come back and say, yes, this person does have a license, they can use it. Then we'll automate things on Archer 2 such that your user account is added to the correct package group, and then you should be able to verify that if you type in groups on your Archer 2 login prompt. So that's not very exciting. If I go into my main Archer 2 account, which is in a different project, if I type groups, that's a bit more exciting. You see, at some point I've helped users of OneTep. That's why I'm a member of the OneTep package group. But that's the sort of thing you'd be able to confirm. If you'd asked to join the VASP group, you'd expect to see VASP there. So you'd get an email confirming that you've been added to the group, and you can just check that for yourself. And then you would be able to submit a job, and you would be able to load, you would load the VASP module, and you would be able to then see the VASP executable, and you'd be able to run that from your submission script. So recording research outputs, there's a special way of doing this within the SAFE. It provides a mechanism for uploading document object identifiers, DOIs, and then you can do that. I don't think there's a menu there, your details, publications. So that's how you would find that. So you would choose the project that the publication pertains to, and so on, and so that starts the process. You can also report on your use of the service and things like that. I think I'll try and show that for the, see if I can, yeah, I can go here. I can see if I can do a report for the TA082 project. There's things down here, so let's look at, they won't have run many jobs, but let's see, it can do project jobs here. This form, this bit is a little bit complicated, I think. So from midnight on the 1st of October, so that's a long time in the past. Maybe I want to make that November. I'm going to do one block of 1 month. So let's do that then. And the resource pool is obviously Archer 2, and we can do like a preview of the report that's returned. So this is returning a list of the users that have run jobs, and I can see the job names, and I can see the users, and it just seems to be me who's run jobs. If anyone else has run jobs, I would have thought you would have appeared in here. Okay. So has anyone run a job within their training account? So that's, they've logged into their TA082. I just want to check. I'm not sort of, okay. Oh, thanks, Eleanor. So I just, yeah, that's what I said earlier, didn't I? So the jobs that I run today won't appear. Yeah, thanks for that reminding me. So you can see my jobs. Yeah, I didn't check that. They were run on the 18th of November. So if I check later, if I check tomorrow, I should appear. I should see the jobs that ran today. But that's the sort of thing you would do. I think it also does pie charts as well for some reports. But I think you won't see anything that detailed for the project I'm showing here, because there are not that many users and not many jobs have been run. So that's reporting in the SAFe. Is everyone? Does anyone have any questions on this part of the course? Can just post in the chat if you think of something. I'll move on to next steps. What you would now do in using Archer 2. I mentioned the Archer 2 service desk. You can always contact them at this email address. You don't have to submit the query through the form that's available via SAFe. And then I've mentioned all of the documentation that's available, the quick start guides that kind of minimizes the amount of information you need to plow through to actually get started in Archer 2. That's quite convenient. And then there's the more detailed Archer 2 user and best practice guide. And then you've got specific pages, pages on specific codes, such as Nemo, which is actually a useful page. And then we've also got our Archer 2 training, the various courses that we have. Let's just go back to that. So this is on, it's not within the Archer 2 documents, the docs site, but on the main Archer 2 site. And we've got our training menu, and we've got the training materials repository. And you can see we have things to do with an introduction to OpenMP, which obviously we did a hybrid job, and we mentioned OpenMP there. We've got things to do with specific codes. I think FireDrake is a CFD code. We've got things to do with Python. So there are many courses down here. I'm just looking for, we got Archer 2 for data scientists. I'm trying to find something to do with Earth systems modeling. I think NCAS generally run their own courses. There's nothing that we actually do independently within EPCC. Well, never mind. Getting access to Archer 2 can be done in various ways. And again, you can explore that through the main Archer 2 website. And we've got Archer 2 there. There's something else I quickly show. There's a status page, which shows you what's going on at Archer 2 right now. And in blue are all of those nodes that are allocated to jobs. And you can see it's most of them. And if you look at which ones are idle, that's like the dark green. There was a few that were idle then at that time, but right about now, there's not many. So if you submitted a job, it probably wait a bit. And we also have some service alerts on here if you've missed anything via email. So this is a page that's sometimes worth consulting. So I was just going to talk about ways of accessing Archer 2. There's the main way, which you go through the partner scientific consortia. That's EPSRC, the Engineering Physical Sciences Research Council, and NERC. I think that's the Natural Earth Research Council. I might have that wrong, but it's generally to do with Earth systems modelling. There's something known as Archer 2 pump priming, where you just want to use small amounts of time. You have to do proof of concept work. There's obviously we accept applications from research grants that aren't to do with either EPSRC or NERC. I think the charging rate for the compute resource is a higher rate, but there you go. EPSRC and NERC did provide money for Archer 2. So there's things for project work that's going to use large amounts of Archer 2. So that's known as the Access to HPC or Pioneer Project research course. So you're using jobs that are requiring thousands of nodes. And again, yeah, we just come from this page. That's the link to the main Archer 2 website. All of these, what I mentioned, it focuses on doing scientific work with research codes on Archer 2. It may be that you need to actually add functionality or improve your code before you can use it to do science or to do publications. And we have a mechanism called embedded CSE, eCSE. I think the CSE just stands for computer science engineering. And that's where you have a more kind of a project that will probably run for a year, say, and may even use a member of EPCC to work on, to advise you on how to write your code so that you maximize the parallelization opportunities. And that's what you would do if you wanted to improve your code such that it can run on multiple nodes and can scale well. That means that the performance or the runtime improves as you expect as you run on more and more nodes. So yeah, so Archer 2 has a lot of documentation. It's I would say it's up to date. There's always a few things, but you can anything serious, if you were to send an email, that would be fixed quite promptly. There are lots of training opportunities, and crucially we do record all of the training materials so that they're available afterwards. That's really useful. And you can get access to Archer 2 via a number of different routes, and so on. So this last bit, we're going to bootstrapping your use of Archer 2. We want to the main thing here is to address is how you intend to get started with using Archer 2 rather. And I guess this is like a general question for everyone. Does everyone feel that they have enough information, or they know where to get information in order to start using Archer 2? Is anyone not certain about something? I guess, I mean, are people, are they intending to run jobs in Archer 2 quite soon? Will they be running jobs next week, for example, or is your use of Archer 2, are you just doing it early? You just attended this course a bit earlier before you intend to use the machine? Okay. Okay. And you feel, yeah, around December. And I know with you, Ruben, you're planning to use the code, so you'll have a bit of setup work to do on the Puma machine. Okay, and the same for Alistair too. Yeah. So because the code, you're basically doing climate models, and it's a very complex code to run, and there are very, very many options which you need to specify how things are going to be arranged on the hardware itself, but also the nature of the simulation that you run. Everything has to be tightly recorded so that this work can always be reproduced. And I think, oh, he's a different, okay, but not for a few months or so. So what we're going to do now then, I think I was just trying to work out if anyone had a particular setup that they were hoping to run soon, and it was going to be a setup that they were intending to run directly on Archer 2, but that doesn't seem to be the case. So we can go to an example in these notes. And this example uses a molecular or biomolecular modeling package called GROMACS. I guess GROMACS stood for something one time or another, some kind of initialism, but it's become too well known to actually use, so we just refer to it as GROMACS. So we're going to, this is a sort of a scientific code that you may use to do science, but this obviously in this example we'll use it directly on the Archer 2 logging node. So this is an example that I can go through. Okay, I've just seen the post from Ben Neal. That's fine. So I just log into my training account and quickly go into my CDW. By the way, I've recorded the details. I've posted the details of that command down here if you're interested on the Ethernet thing, on the Etherpad page. So I'm in here and I created a section, a folder called GROMACS, and I've got my submission script in here. And I guess no one in the audience is familiar with biomolecular modeling. Well, neither am I really. So what this is doing is just running a GROMACS job over 4 nodes, and they're fully populated. So we're using all 128 cores across the 4 nodes. It's at 512 in total, and I'm loading the latest GROMACS. I think that's available on Archer 2, and this is the command itself. So I'll go through this. Again, I'm just using the standard distribution block. I have the hint such that I'm not going to use hyperthreading, using 1 process per core. I've got this option for some reason where it just means that the directory I'm running this job from will be the directory that I submitted the job from. It's probably not needed. Now, as I say, this is all part of the srun command. I've just got this backslash is just the line continuation character. So this is all part of srun, and this is the GROMACS executable for doing parallel work. And these are the parameters I need to pass to it. The MD run is to tell it I'm going to do a molecular simulation. -s, this is the path to my input file. So what I'm doing here, you probably wonder what this means. So the tetra meaning 4. So this is 4 somethings, usually molecules, though this is 4 molecules that kind of bind to each other, and I've got a pair of these. So I've got two sets of 4 molecules, and together they form something called the high epidermal growth factor receptor. So this is something to do with it's to do with your skin, I think with human skin. I'm not entirely sure, but it's a sort of thing that they might use to model the growth of tumors. So you know, it's a thing. It's the type of input that would be used to do an actual science run. And the TPR, I think it's probably archived data. And then I indicate that I want my results, and then I indicate that I run for a certain number of steps. I'm not sure what the time is in terms of the how much simulation time is an individual step, but I can probably find out from the output. So, and then after the job runs, I do a bit of tidy up in that I just move things around and so on, just so that the folder is ready for the next run, should I do that. So I'll just, rather than run that and wait for it to work, well, actually, I don't know if I could do that. I think I'll have to run it because I don't have any. So I'll run that now, and that's my GROMACS job is running. So it's only doing 100 steps, so it hopefully shouldn't take too long. I may have some output already. I do have an output file called gromacs.o blah blah, the job ID. It's now writing some other files. So it started. So this is running across 4 compute nodes. Is it still running? Oh no, it's already coming to an end. So it just ran for 20 seconds, which is good. So it's the perfect job to run as a demonstration. And that has finished. And I think things would have been tidied up. I've got a results folder, and in there is another folder with the job ID, and I've got my GROMACS output file, and I can have a look at that. So there's quite a bit of information that comes out at the top, just like a banner. Oh, okay. So here is I ran 100 steps, and I don't know. I think does that mean that each step was 0.2 of a picosecond? It might mean, and I think that's what that means. So, and the great thing about the GROMACS code that I like is that it will give you the performance at the end of it. So, and it gives you a nice quote as well. But basically, the performance is the interesting thing, because it tells you that in a day's worth of compute time, if this was to run for a day, then you would have simulated 7.759 nanoseconds of simulation time. So that's the performance you'd get. And so, if you ran this on 8 nodes, you would expect that performance to go up, to increase. So we could probably do that now. If we just go into submit, and then we did that on 8 nodes. I don't know, it may be the amount of data that's assigned to each task may be too small, and you may not get much of a reduction in the runtime, but we'll see what happens anyway. Because I mean, it only ran for 20 seconds, and a lot of that 20 seconds may have been taken up with just doing the serial part of the computation. We may see a little bit of an improvement, but not much. So it's running on the 8 nodes instead of 4. I think while I'll do that, I'll just remind myself of what that was. It's 7.8 thereabouts, 7.76. That's coming to an end. And now I have to go back into results again, and it's in a different 7.7 would be a later. Go down that way, slightly faster. It's not double. It's not around 14 nanoseconds per day, but it's what I would expect given the briefness of the runtime. So 11.16 nanoseconds of simulation per compute day. We've got a different quote too. So there you go. That's the sort of thing you're doing to run a more of a realistic use case, I would say. You can explore this further. You can if you want to run your own GrowMax job, you can do that from, I think this is the, yeah, I'm downloading this directly. So that's the same thing that this is, what's that? Yeah, that's the same thing. That's the high epidermal growth factor that's downloading now. But that would be, you download that to my local machine, and then I'd have to use SCP to transfer that across to my Archer 2 account. I might make it a bit easier because I've already got it here. I can go into the inner shared folder. Oh, there's something in there already, but I can just move that in there, and you should have read access. I'm just checking that you'll have read. I can see that there's read there for the group, and indeed for users outside of TA082. So that will save you having to download it to your local machine and then uploading it to your Archer 2 account. You can just copy it from this location. So I'll just give the full location. Oh, oops, it should be coming out. I see, because I'm not listing it, it doesn't. Sometimes the line completion is quite intelligent in that it knows that this TPR file isn't something that I can execute, so it won't. But if it's listing it, it will then auto-complete the line. So just checking that's where it is. It will save you a bit of time if you just want to experiment with GrowMax. So the idea is to write a job submission script. I've given you an example of that. And then you can vary the number of nodes from 1 to 16 nodes. You can see how it improves. So if you were to get a better scaling, maybe you would probably want to increase the number of end steps so that it runs for longer. So that just avoids that means that more and more of the overall compute time is taken up with doing the actual parallel computation rather than all the serial stuff that typically happens when the code starts and when it ends. So you might change 100 to, I don't know, 10,000, but then it will take longer. You have to experiment. You don't want it for it to take too long, maybe only as long as 10 minutes, but you can experiment with that. And then you can do things like you can actually use OpenMP, I think, with GrowMax. So you can do things as was shown earlier. So we come to the end of this course, or the end of the content. I mean, it's scheduled to run until 4, so I'm quite happy to hang around and help people run through this example, to do a GrowMax run, and then to help them with whatever variations that they're interested in exploring. So, I mean, if anyone has any questions, I can answer them now about what I've just talked about, and I can just stay around and be on hand to help anyone as they try to run their jobs within the training account.